All right, let's get right into it. Today, we're going to tackle a concept that is absolutely fundamental to electrical safety: calculating the load on a branch circuit. We're going to break down the essential rules from the National Electrical Code, specifically Section 220.14, so you can walk away from this feeling confident and precise when you plan your circuits. Okay, let's do this. So, to kick things off, here's a weird one for you. Picture a simple hairdryer, something you use every day. Now picture a massive, brightly lit billboard on the side of a highway. Electrically speaking, what could those two things possibly have in common? Believe it or not, the answer is that they both represent an electrical load. And the code is really clear about this. That load isn't just a suggestion, it's a value that you have to calculate. Why? To prevent overloading circuits, which, as we know, is a leading cause of electrical fires. It all comes back to safety. And that leads us right to our main topic, branch circuit load calculation. So what does that actually mean? It's just the official process for giving a minimum power value, measured in volt-amperes, or VA, to every single outlet on a given circuit. You can think of VA as the apparent power. It's what the wiring and the circuit breaker actually have to deal with. By doing this, you're making sure the total demand on that circuit never, ever exceeds what it can safely handle. So where do we even begin? Well, we start by building that foundation for a safe circuit. The great thing is, the National Electrical Code gives us a really clear roadmap, and getting these rules down is absolutely non-negotiable for any safe, reliable electrical system. The code itself is pretty direct about it. This quote from Section 220.14 makes it crystal clear this isn't optional. It says that for basically any type of building, the minimum load for every outlet has to be calculated using the specific rules laid out in subsections A through K. No way around. You know, to make this whole thing less intimidating, let's think of these rules as a mental toolbox. We can organize everything into three main trees. First, we have the knowns. These are for specific appliances. Second, we have the illuminators. That's everything to do with lighting. And third, we have the variables. These are for all those everyday receptacles you see everywhere. All right, let's pop open that toolbox and grab the easiest tools first. We're talking about calculating loads for specific known appliances. See, when you know exactly what's going to be plugged into an outlet, the code gives us a super simple, direct path. And the rule here from 220.14a is just beautifully simple. If you have an outlet that's dedicated to one specific appliance, you just calculate its load based on the amperage rating of that exact appliance. It's right there on the nameplate, no guessing required. The load is what the machine says it is. Okay, but what about the big stuff? For certain high-power items, the NEC actually points you to other, more detailed sections. Think about the heavy hitters in a house. For electric dryers, you're going to go to Section 220.54. For things like ranges and cooktops, it's 220.55. And for motors, you'll need to look at Articles 430 and 440. We're not going to dive deep into those today, but it's super important to know they have their own special instructions. Okay, tool number one is back in the box. Let's move on to the next category in our toolbox, the illuminators. And just like it sounds, this section is all about how we calculate the load for everything related to lighting. So for lighting, the rules are, again, pretty straightforward. For a standard light fixture, a luminaire, you just use the maximum VA rating of the fixture and the lamps it's designed for. Easy enough. For those really big, heavy-duty lamp holders, you have to assign a minimum of 600 VA. And for things like commercial signs and outline lighting, that load jumps up to a minimum of 1,200 VA for each branch circuit that's required. But here's where things get kind of interesting. When it comes to show windows, like in a retail store, the code actually gives you two different options. Option 1. You can calculate the load for each lighting outlet one by one. Or option 2, you can use a much simpler method. Just assign 200 VA for every linear foot of the window. The really important part is you have to pick one method and stick with it for that calculation. Okay, so we've covered the knowns and the lights. Now for the last and honestly the most common tool you'll ever use from this toolbox, the everyday receptacle outlet, the variables. Since you can't possibly know what someone's going to plug in, the code gives us very specific default values to use. Seriously, if you remember one thing from our chat today, make it this number, 180 VA. This value is the absolute cornerstone for calculating general use receptacle loads. Let's see how it works. So here's the deal. Under 220.14i, each standard receptacle point, and that means a single outlet or even a duplex outlet on a single yoke, gets calculated at a minimum of 180 VA. But there's a big exception here. If you have a single piece of gear with 4 or more receptacles on it, like a power strip, the calculation changes. It becomes 90 VA per receptacle. That's a huge difference, so remember that one. Now, speaking of special cases, you've probably seen these in commercial spaces, right? Those long, continuous strips of outlets you find on workbenches or in labs. The code calls these fixed multi-outlet assemblies. So for these long strips, it all comes down to one question. How are they going to be used? If it's an area where it's unlikely a bunch of things will be running at once, you assign 180 VA for every 5 feet of that strip. But if it's a high-use area, like a busy workshop where everything is likely to run at the same time, that load gets way denser. It's 180 VA for every single foot of the assembly. You know, office buildings get their own special treatment in the code. It actually makes you do 2 separate calculations for the receptacles. First, you have to add up all the outlets using our 180 VA rule. Then, you do a second calculation, 1 VA for every square foot of the office space. And here's the kicker. You have to use whichever one of those 2 numbers is larger for your final load calculation. And finally, what if you run into something totally weird that's not on our list? Well, the code has a catch-all for that. Subsection K basically says if you come across some other kind of outlet that isn't covered by any of the other rules, you just calculate it at 180 VA. It's the default value, a safety net to make sure nothing gets missed. Okay, our toolbox is officially full. We've got the rules for specific appliances, for all kinds of lighting, and for general receptacles. We know how to assign a VA value to pretty much any outlet you can think of. So now, it's time for the final most important step, putting all those tools to work. And the final step, honestly, it's the easiest part. You just go down the line, outlet by outlet on a single branch circuit, apply the right rule from 220.14 to each one, and then you just add them all up. That final sum is your total calculated load for that circuit. Simple as that. So let's just boil this all down to a super simple 4-step process for safety. Step 1, identify every single outlet on the circuit. Step 2, calculate each outlet's load using the rules we just covered. Step 3, sum them all up. And step 4, use that grand total to correctly size your circuit breaker and your wires. That's it. That is the fundamental path to a safe, code-compliant installation every time. And that's it, a clear breakdown of NEC 220.14. These aren't just random numbers in a book. They're the bedrock of electrical safety, designed to protect property and, more importantly, people. So now that you've got the rules in your toolbox, the only question left is, what are you going to go build safely? Thanks for tuning in.